Hi, this video is made for the study on the influence of political agreement and sanctions effectiveness. Economic sanctions are simply measures intended to alter the behavior of a given state. And this research will attempt to resolve a recurring empirical question in world politics literature concerning the association between international relationships and economic sanctions by using this definition. And when we look at the literature made on economic sanctions, we see three main phases. The first phase started from 1970s to 1980s, and one of the most significant scholar in this period is Galtung's work on Rhodesia. And, and according to him, sanctions are not effective foreign policy tools. In the second phase, we see this from 1980s to 1990s, the study of economic sanctions became more rigorous, and we see more quantitative models, especially the data set provided by HSE contributed this approach a lot. And then during the 1990s and still ongoing, especially this phase started after the dissolution of Soviet Union because countries used economic sanctions more than before, especially after the Soviet Union period. We see more databases and contribution from many different perspectives. And one of the most important data provided in economic sanctions is by, made by Morgan et al. And this phase especially has produced new definitions, metrics, and approach to the investigation of economic sanctions. Especially during this phase, we see that the most important question discussed by scholars is are economic sanctions successful or not successful? If it is successful, are unilateral sanctions are more effective or multilateral sanctions are more effective? When we look at the literature, we see that Dresner, Mears, and Morgan, and Buffett and Morgan says that unilateral sanctions are more effective. And then Mansfield, Dresner, and Thompson says that coalition sanctions are more successful. We know Galtung noted that sanctions are not effective foreign policy tools, and he said domestic factors are very effective on politicians' decision making. And that's why most of the time, especially in democracies, we see the problem of the consensus. However, in the Mansfield argument, the ability of policymakers to assume high cost is the most important factor making decisions whether sanctions should be imposed or not. So, especially the debate on unilateral or multilateral sanctions are focusing on the bargaining dilemma among participating states on economic sanctions. And for Lexine and Peterson, coalition sanctions are not very successful because there is bargaining dilemma between senders. And also Martin and Posner and Sykes and Pollack argues that this unilateral defection is always possible. And then when we look at my study looks at the domestic factors, the influence of domestic factors on the success of economic sanctions. And my theory is I'm looking at the influence of domestic opposition, whether the decision made by domestic opposition influenced the effective sanctions or not. So for this, I made three hypotheses. My first hypothesis is the higher the levels of political agreement on demands shared by crucial actors in sanctions are associated with sanctions that are more effective. And the second hypothesis is the higher level of political agreement on demands within the sender state are associated with more positive economic sanction outcomes. And the third hypothesis is lower levels of political agreement on sanctions demands within senders are associated with with ineffective economic sanctions. So this study is an ongoing study. Right now, I'm working on unilateral sanctions and domestic factor, but I will develop this by looking at multilateral sanctions as seen in my hypothesis. So for the sake of this study, I'm only looking at one-to-one case dyadic relationship between one sender and one target, and I'm looking at the influence of uh, domestic opposition on the success of economic sanctions within the sender state. And I'm using formal model for that, and my dependent variable is the effectiveness of economic sanctions, and my main independent variable is the level of political agreement, and my units of analysis is the economic sanction episodes. My level of analysis is the dyadic relationship between senders and the target. But for this study, it is one sender and one target. Yeah, the level of political agreement. As I said, I'm looking at the influence of domestic opposition. I have two models where uh, there is opposition and there is no opposition. In the first model, I only have two actors, and those actors are uh, S1 and S2. S1 is the sender state, and S2 is the target state. And we see that S1 first threatens the sanctions and then imposes the sanctions, and S2, the target state, either obeys or challenge. And in the second model, I have one more actor, and this is opposition, the green colors. So first the sender either threatens or chooses status quo, and then the opposition either supports or opposes sanctions policy, and then the target either obeys or challenge. And then if the target obeys, then the game ends, and if the target challenges, then the sender either backs down or imposes, and then the game ends here. But at the beginning, if the sender chooses status quo and the opposition either choose or oppose, and the game ends here. First, I will look at the first model. So here we only have two players, S1 and S2. And then I will look at the second model after that. And to calculate the utilities here, we need to know the probabilities of actions that players will choose strategically. So here, if the S1 threatens economic sanction and S2, the target state, obeys, then the game ends, and it's S1 getting the most of the payoff. And if the sender state S1 chooses status quo, then the game ends, and then the second player S2 gets 1, and then sender gets 0. What if S2 challenges? This time S1 either imposes or backs down. So here we don't know the payoffs. We need to find them. But for this, we need to use Bayesian probabilities. So we need to look at cumulative distribution frequencies. Hypothetically, I said that we have three main decisions for the sender state. So one is status quo, second is threatening, and the third is threatening, imposing sanctions given threatening, or backing down given sanctions are threatened. So here I showed them, and those are the probabilities, and this is the probability functions, and this part is the So this is not necessarily like a increasing function. So this can be a different function, but for simplicity, I show it in this way. So we will calculate the values for x or fx or y or f of y or f of minus a by using a Bayesian probabilities. So, for example, for the case where government imposes economic sanctions, given sanctions are threatened, is Bayesian probability says that we need to look at the case where first government imposes where government impose probability of government impose economic sanctions times probability of government threatening sanctions given sanctions are imposed divided by probability of government imposing sanctions times probability of government threatening sanctions given sanctions are imposed plus probability of government backing down times probability of government threatening sanctions given that sanctions are given that the government backing down. So here IS means imposing sanction, TH means threatening sanctions, and then BD means backing down from the sanctions. So those are all strategies chosen by the government or S1 or the sender. Here I say government because I'm looking at the within the state, like domestic politics of the sender state here. But now this is the first model and we don't have a position. And then for the case, for example, where the government imposes sanctions, given sanctions are threatened, here, the same model. And we need to look at from the CDF function table here. And then by looking at this table, if we plug those values, and this is what we get, and then this is what we get for government imposing sanctions, because if the government imposes sanctions, here it is the imposing stage, and then this is the f of minus a. So this probability divided with the whole probability, and this is what's here. So this is f of y. It's the same with f of ya, f of minus a. I use y for simplicity, but this is the region of this part. And then government threatening economic sanctions given sanctions are imposed is 1, because if we see, as we see here, either of those choosing one of those strategies given sanctions are threatened is for sure. So this means that if a country imposes economic sanctions or backs down, first it has to be threatened. So that's why it's 1. And then government imposing economic sanctions given sanctions are threatened. This one. After we plug those values, this is the result that we get. 1 minus f of y divided with 1 minus f of x. And then government backing down giving sanctions are threatened. So government backing down given sanctions are threatened. Just before we looked at the government imposing sanctions and government sanctions are threatened, so we get the probability of this strategy, and now we are getting the probability of this strategy. And here, it's the same formula coming from the Bayesian conditional probabilities, and then after we plug those values from the CDF table, simplified CDF table, and then we get this result. This is 1 minus, we get this result, and this is f of y minus f of x divided with 1 minus f of x. And then we need to get values for those probabilities. How can we get them? For this, I'm using the TICE dataset introduced by Morgan et al. So TICE means Threat and Imposition of Economic Sanctions dataset. I'm using the version 2013, and here I looked at all the cases that they used uh, as long as sanctions are first threatened. So in Thai's data set, we see different stages of economic sanctions. One is sanctions are imposed, and the other one is sanctions are not imposed, sanctions are threatened, and sanctions are not threatened. And now, if I look at all of those cases and probabilities, those are the probability numbers that I get. And then after I plug those values here in our table, CDF table, uh, and this is what we get. So government choosing status quo is 20%, 26% probability, and threatening backing down is 38%, and threatening impose is 36%. And then I look at my my payoffs, and here I need to have a payoff in this game, a combination of U2 and 1 compared with 0. Because if this combination of those payoffs are bigger than 0, then S2 will choose challenge. If it is lower value, then S2 will choose obey. And then after I plug the values that I get from the probability table, and this is what I get. So the U2 should be bigger than minus 1.06. And then also in the model 1 with no opposition, the government chooses the strategy of imposing sanctions only when minus A is bigger than U1. So here we need to look at again. So if the minus A minus is bigger than U1, then the government backs down. If U1 is bigger than A minus, then the government imposes sanctions. So if I plug those two values to the graph, then I get this results. And U1 is the payoff for the first player, sender, and U2 is the payoff for the second player, target. So this is the dark side, is the combination of payoffs for these players. So let's leave this aside and then look at the payoff graph for these two players after the introduction of opposition. So here it's the same model, my second model, and I introduced my opposition here, and now I have three players, and that's why I have three payoffs here. The first payoff is the sender, the second payoff is for the opposition, the green color, and the third payoff is for the target state, S2. Yeah, so here I need to look at the Bayesian probabilities as well. The same approach and everything is the same way. But here, how can we know when the opposition supports or when the opposition does not support the sender? So if the opposition have a decision making on this option, then the opposition, we know that, has information about about the government's decision more than the sender. So that's why we shouldn't expect an opposition to support government's policy before the threatening stage, because if it is when we look at the importance of the issue, so if it is at this level, so this might not be a very important issue for sender, but if it is over this probability, and if the probability is within this region, so this means it's something very important for the opposition, so they can support or does not support. So the cut point for the opposition should be somewhere within Y and P, and for simplicity I accept this z1, z2 divided by 2. Here z1 is y and z2 is p. And then I will use this table again that I got from Ty's dataset. And then after getting fy and fx values from this table, and after I plug them, and this is what I get. So those are the percentage probabilities for the options, for the strategy options for the players. And then here I also show that fz is the CDF for opposition, and it's up to this way, this cut point. Now we need to look at two things: when opposition supports and when opposition does not support. So if the opposition supports, probability of government backing down, given that opposition supports, is this probability that we get it from the Bayesian probability formula. And then after we plug the values from our CDF table here, then we get this result. So government backing down given opposition supports is 0. So this tells us that as long as the opposition supports, the government never backs down. And then here we see that probability of government imposing sanctions given opposition supports is 1. So I want to say here that yeah, it is similar. Logic here. So probability of government imposing sanctions given opposition supports is, if it is 1, this means government always impose sanctions if the opposition supports. So then I need to compare my values, payoff values for the government, and here I assume that combination of strategies here should be bigger than 0. So I got those probabilities from Bayesian estimates, and then after I plug them, I will get U2 here, and then here I plug those numbers, and then I got U2 bigger than minus 1.06. And so this is for U2, and then this is for, again, for U1 it should be bigger than minus a, as I discussed in the first model. And then after I put those results in the graph, and this is what I get. So this is the payoff when the opposition supports, and orange color is for the first player sender, and the dark color is for U2 target state. And then now what happens if the opposition opposes? Sorry, I need to correct. So this is what happens when the opposition supports. That one was for the game without opposition. So here we see that the payoff for the target gets much more lower. So this means if the opposition supports the government, then the target state gets lower payoff. And what if the opposition does not support? And again, the same steps, Bayesian probabilities, and then using CDF table, and then plugging those values, and then we get this graph. And here U2 is bigger than here. So if the opposition supports, U2 is smaller. U2 is the payoff obtained by the target state. If the opposition opposes, then U2 gets bigger. The target state gets more payoffs. So in our first model, we looked at the case where there is no opposition. And if there is no opposition, then we should expect a value between these results. And then, when we'll put all of those three graphs together, this is what we find. In the sub-game perfect equilibrium condition, we see that S1 and target state has changing payoffs in all of those conditions. So if the opposition supports, then U2 gets the lowest payoff. If the opposition, there is no opposition, the only players are only sender and target, and then the target has no other source to get information other than the government, then this is the payoff. And then if the opposition does not support the government, then U2 gets the highest payoff, because U2 get this information that the sanctions policy of the government is not supported by the domestic politicians, and that's why the government can challenge the sanctions threats or sanctions threats of the government. And this model suggests that opposition parties can serve to send credible signals to sender states. And also the opposition's refusal for the government's decision on economic sanction decisions decrease the sanctions outcomes effectiveness. Therefore, domestic actors' agreement on the economic sanctions affects the result of economic sanctions. So the level of political agreement is the factor here in this game that is changing the target's payoffs. And we should also look at this by comparing the influence of public opinion, lobby groups, and the international factors. And by saying international factors, I'm saying that there might be more than one senders. And the next step of this study will be looking at those influences on economic sanction outcomes. And this is the result of this study. Thank you so much. Thank you for listening.